Alright, welcome to today's video. Today we're going to be talking about multiple representations of linear functions, or multiple ways to represent the same straight line. Okay, we're going to be dealing with kind of 4 different ways to represent it. One of them is going to be an equation, the other one's going to be a graph of the equation, one will be a table of values, and then the other one will be some verbal descriptions or some questions that you need to answer kind of about that. So, you'll be given one of them and you will have to kind of fill in the rest of it. Okay? So we see from this first one here, we're given the equation, and we're given that equation right here. We're given the equation and then we need to fill in the rest of it. And we know how to do all of this. It's just kind of putting all of these skills together. So let's start with this equation and let's go to the graph. I know that y equals mx plus b. I have a slope and a y-intercept. That slope is -1/2 and that y-intercept is +5. So my y-intercept is +5. My slope is -1/2, so I'm going to go down 1 over 2. Down 1 over 2. Okay, and remember we learned we can go the other way. Instead of going down 1, we can go up 1. Instead of going right, we could go left. So up 1, left 2. And I have my 5 points to make my line. That's not very straight, but I think you kind of get the idea here. Okay, so that's how to go from the equation to the graph. Now, we could also go from the equation to the table of values. We can pick values for our x, plug them into the equation, and find our y. Well, if we look at this equation here, I have a slope of -1/2. So I want to pick x values that are divisible by 2, that denominator. Okay. So let's pick -2, 0, 2, and 4. So if I plug in -2, what's going to happen? Let's take a look here. -1/2 times -2 plus 5. Well, -1/2 times -2, negative times a negative is a positive, 1/2 of 2 is 1, plus 5 is 6. Okay, and if we look, that's this coordinate point right here on the graph. -2, 6. Okay, so the graph in the table of values, you wouldn't necessarily even need the equation. You could go from one to the other too. All right, so as we said that was 6. All right, 0. Well, when x is 0, that's your y-intercept. So that's this one. Okay. Or, looking at the graph, that's that point. So 0, 5. And when we were talking about table of values, we said we can start to notice patterns here. I'm seeing that as I'm starting to go down by y, I'm decreasing by 1, and as I increase x, I'm adding by 2. Well, that kind of looks like a slope, a change in y divided by change in x. M equals -1 over 2. Well, that's what our slope is in this equation here, -1/2. Okay, so a lot of things are kind of connecting here, and there are different ways to represent the same thing here. So I can keep following this idea of slope, decreasing by 1 as I increase x by 2. And that's kind of why I chose my x values to be divisible by 2. So then this would be 4, and that would be 3. So that's our table of values here. Let's always try to do at least 4 points. Okay. A verbal description now. List 3 points that are a part of the solutions that are not in the table of values. Well, we can keep using this idea of slope. Decrease y by 1, increase x by 2. And we can list it as a coordinate point. Well, the next point would be 6, 2. So that's one I'll list here, 6, 2. And I can keep going with that. 8, 1. Okay. And then 10, 0. Alright, so there's three other parts there. Now, how many solutions exist for this equation, and how do we represent that on a graph? Alright, well, there are infinitely many points that work in this graph. That's why we draw that line. And that answers the second question. There are infinitely many points, and we represent that with a line. Okay? So, you get the idea there. I'm not going to take the time to write that out. It would be infinitely many points, and we draw the line to write that in. Okay? So this is multiple representations of that same equation right there, y equals negative 1/2 x plus 5. Let's take a look at another one here. This time, we're given a verbal description, and we need to kind of fill the rest of it in. It says, your equation has a slope of 3 and a y-intercept of negative 2. So that's my equation, and I'll write that back up here. Y equals 3x minus 2. Well, that's a slope of 3 over 1, so I can graph that. Shoot. There we go. So I can graph that here. Y equals 3x minus 2, starting at negative 2. 3x over up 3 over 1. Okay, down 3, left 1. Sorry about that other line there. So, that's our line. Okay, and we can use those points and we can write our table of values in here. Well, that first point, the first one all the way down here, would be negative 2, negative 1, 2, 3, 4, 5, 6, 7, and 8. So negative 2, 8. Okay. Then the next one would be negative 1, negative 5. And we can see this slope starting here. As x increases by 1, y increases by 3. Change in y divided by change in x, 3 over 1. Okay. Those are negative. I forgot to add that in. That makes more sense now. So negative 2, 0. Well, that's the y-intercept from the equation. We can go one more, 1 and positive 1. That's it for this one. Let's take a look at another. This time, as we can see, I'm not given an equation or a graph. However, I am given the table of values. And like we've already talked about, we can determine our slope from the table of values. It's going to be the change in y divided by the change in x. Every time here, my y is decreasing by 3, and my x is increasing by positive 2. So change in y divided by change in x gives me a slope of negative 3 over positive 2, or negative 3 over 2. And that answers one of these questions here. From your table of values, determine the slope. Well, we just said m was negative 3 over 2, so let's write that down. Okay, well, thinking about our y-intercept, let's just go and look at our graph real quick. The y-intercept always occurs when the line crosses that axis, right? Okay. So the line crosses that axis, and on my x-axis, the x value at that line, like this point here, is 0, 0. Okay, or this point here is 0, 5. So all of the points on the y-axis, have the coordinate, or have the x-coordinate of 0. So in our table of values, we can look to find where x is 0. And that's right here. So that gives me my y-intercept. B equals 5. So B equals 5. Now I can write an equation from that. Y equals negative 3 over 2x plus 5. So that's what we'll fill in here. That's our equation. Now let's go to the graph. Okay, positive 5, negative 3 over 2, down 3 over 2, down 3 over 2. We could go backwards. We could go up 3, left 2. Oh, I can't put another one on there because it would take me off of my graph. So 4 in this case is sufficient. And there's my line. Alright, so this is multiple representations of functions, and I have one more to do here. As we can see, we are given our graph. Okay, I see that my graph, my line intersects the y-axis right there, so that tells me b is positive 2. Now let's find a slope. Oh, it crosses up here as well. That's a rise of 2, a run of 4. Well, 2 over 4 is 1/2. Okay. So now I can write that equation, y equals 1/2 x plus 2. Okay. Let's scroll down here now. Let's look at our verbal description here. From the graph, what is the slope? Oh, we already answered that. That was m equals 1/2. From the graph, what is the y-intercept? Okay, well, that y-intercept was 2, so we'll say b equals 2 here. Okay, and then the other one says, from your graph, identify 4 points and include them in the table of values. So we don't actually need to write anything down there. It's just giving us some instruction on how to fill in our table of values here. Well, we have that y-intercept of 0, 2. We have 1 to the left of that at -1, positive 2. There's another point there, positive 2, positive 3, and then another one over here, 4, 4. So those are the ones we'll include in the table of values. -1, positive 2. That y-intercept, no, that was -1. I got that backwards there. I'm sorry, that was -2, positive 1. Then our y-intercept of 0, 2. And then the next point was 2, 3. And then the next one was 4, 4. And look at that. You can see the slope in this table of values and how it corresponds to that equation and the graph. Okay, y is increasing by 1, x is increasing by 2, change in y divided by change in x, 1/2. Okay, that is the end of this video. So if you're a little confused on all of this multiple representation stuff, we'll go over it again in class. Okay. Hopefully you took notes today. It would have been a good day to take notes. Maybe go back and rewatch it and take some notes on this.